Every time you type a question into ChatGPT or ask Claude to write something for you or use Gemini to summarize a long document, there is one piece of technology sitting at the center of all of it. It is called a large language model, or as everyone calls it, an LLM. Now, most explanations of LLMs will immediately throw words at you: transformers, neural networks, attention mechanisms, token prediction, and within 30 seconds, your brain has quietly switched off. I do not want that to happen today. So, in this video, we are going to build your understanding from the ground up. No jargon, no shortcuts. By the end, you will not just know what an LLM is, you will actually understand how it works. Let us begin. Let us start with something you already know. When you were a child, you learned language by listening and reading. You heard sentences, you saw words. Slowly, over years, your brain figured out the patterns. You did not memorize every grammar rule first. You absorbed the language from millions of examples, conversations, books, stories, jokes. And your brain built an internal model of how language works. A large language model does something remarkably similar. It reads a huge amount of text, and I mean enormous amounts. Articles, books, websites, research papers, code, conversations, billions and billions of words. And from all of that reading, it learns the patterns of language. Which words tend to follow which other words? How sentences are structured? What a question looks like? What a good answer sounds like? What makes an explanation clear versus confusing? That is the core idea. An LLM is a system trained on massive amounts of text that has learned the deep patterns of human language. Now, why do we call it large? The large refers to two things. First, the amount of data it is trained on. We are talking about text that would take a single human thousands of years to read. Second, the number of parameters inside the model. Parameters are, in very simple terms, the knobs and dials inside the model. Each parameter holds a small piece of learned knowledge, a tiny fragment of a pattern the model has picked up from all that text. Early language models had a few million parameters. GPT-3, which came out in 2020, had 175 billion. The models today are even larger. Think of it this way. Imagine you are trying to describe a person's face. If you use 10 numbers, you can capture very rough features, perhaps just height and weight. If you use 10,000 numbers, you can describe facial structure in detail. If you use a billion numbers, you can capture every micro expression, every unique detail. Parameters work the same way. More parameters means the model can capture more nuance, more complexity, more of the richness of language. That is why these models are called large. The scale is genuinely staggering. Okay, so the model has been trained on enormous amounts of text. It has learned patterns. But how does it actually produce a response when you talk to it? This is where it gets interesting. At its core, an LLM is doing one thing: predicting the next token. A token is roughly a word or sometimes part of a word. When you send a message to an AI, that message gets broken into tokens. The model looks at all those tokens and then predicts what token should come next. Then it adds that token and predicts the next one, and the next, and the next. It is generating your response one token at a time. Each prediction informed by everything that came before. Now here is what makes this powerful. The model is not just looking at the last word you wrote. It is considering the entire conversation, every word, every sentence, everything in context. And because it was trained on so much human text, its predictions are not random guesses. They are informed by deeply learned patterns of what makes sense, what is relevant, and what is useful. Think of it like this. If I say to you, the sky is, you immediately know what comes next. Not because you memorized that sentence, but because you have absorbed so much language that the pattern is natural to you. An LLM has done this for essentially every kind of sentence imaginable, at a scale no human could achieve. That is the engine behind every AI conversation you have had. Let us talk briefly about how these models are actually trained, because this helps explain why they are so capable. Training happens in stages. The first stage is called pre-training. This is where the model reads that enormous corpus of text and learns to predict tokens. It sees a sentence, it tries to predict the next word, it compares its prediction to the actual word, and it adjusts its parameters slightly to do better next time. This happens billions of times across billions of documents. It takes weeks of computing on thousands of specialized chips working in parallel. After pre-training, the model knows a lot about language, but it might not be very helpful yet. It might produce text that is technically coherent but not what you actually wanted. So there is a second stage, fine-tuning and alignment. In this stage, human trainers give the model examples of good, helpful, safe responses. The model learns not just to generate plausible text, but to be genuinely useful, honest, and careful. This is what turns a raw language model into an AI assistant you can actually have a productive conversation with. Different companies, OpenAI, Anthropic, Google, Meta, have built their own versions of this process. Each model has its own character, strengths, and areas of focus, but they all share this fundamental architecture. Here is something that surprises most people when they first learn about this. LMs were not explicitly taught to write poems or solve maths problems or explain legal concepts or write code. None of that was directly programmed in. These abilities emerged from the training process. From reading enough text across enough domains, the model developed general capabilities that nobody specifically designed. This phenomenon is called emergent capability, is one of the most fascinating and debated aspects of modern AI. When a model has absorbed enough knowledge, things start to click together. It can reason through a problem it has never seen before because it has internalized the patterns of how reasoning works. It can write in a particular style because it has seen thousands of examples of that style. It can answer a question about tax law because it has read enough legal text to understand the structure of that domain. This is also why LMs sometimes make mistakes in surprising ways. They are not databases that look up correct answers. They are pattern matching systems that generate plausible responses. When the patterns in the training data are sparse or ambiguous, the model can confidently produce something that is wrong. Understanding this limitation is just as important as appreciating the capability. The best way to use an LLM is to treat it like a very well-read, thoughtful collaborator, not an infallible oracle. Now let us make this real for you. Every time you use ChatGPT, Claude, Gemini, Copilot, or any of the dozens of AI tools appearing in your workplace, there is an LLM running underneath. When you ask it to summarize a document, it is generating a summary token by token based on patterns of what good summaries look like. When you ask it to write an email, it is generating text that fits the pattern of professional communication it has absorbed. When you ask it a question about cybersecurity or finance or health, it is drawing on patterns from all the relevant text it was trained on. In the professional world, especially in technology, banking, and financial services, LLMs are becoming embedded in every layer of the workflow. Drafting, analysis, research, code review, policy interpretation, risk summarization. You do not need to be an AI engineer to benefit from this, but you do need to understand what you are working with. And now you do. Let us quickly recap what we covered today. A large language model is a system trained on vast amounts of text which learns the deep patterns of human language. It works by predicting the next token one step at a time, building responses that feel natural because they are grounded in billions of real examples of human writing. The large refers to both the scale of training data and the number of parameters inside the model. It is trained in stages, first to understand language, then to be genuinely helpful. And its surprising capabilities, from coding to reasoning to creative writing, emerge from the training process, not from explicit programming. That is the foundation. In future videos, we will go deeper into how these models are changing specific industries, how to use them effectively at work, and what the limits and risks actually look like in practice. If this video was useful to you, please share it with one person who is curious about AI but does not know where to start. That is exactly who this channel is built for. Hit subscribe if you want to keep learning without the jargon. I will see you in the next one.